I am Mrs. P. Jyoti, working as an assistant professor in EC department in Srivasavi Institute of Engineering and Technology, Nandamuri. Today we discuss about the timer programming in 8051 microcontroller. So in 8051 microcontroller there are two timers, timer 0, timer 1. Timer 0 and timer 1. These two timers are 16-bit timers. 16-bit timers. This 16-bit timer can be divided into higher byte and lower byte. Higher byte and lower byte. So this timer programming means 8051 can be programmed for delivering the required time delay. So first of all, we have to select any one of the timer register. Let timer 1. Let me take timer 1. So this timer 1 register can be loaded with the required initial value. Let 7, 6, 3, 4, 8. From this value, the timer starts counting and it reaches the maximum value. Maximum value means for a 16-bit register, what will be the maximum value? Maximum value is the H. So each digit 4 bit represents 4 bits, total 16 bits. It is the maximum value. From this initial value, the counting starts and reaches the maximum value. Whenever it reaches the maximum value, timer overflow will be occurred. So before going to write the programming, we have to select one of the mode. It provides 4 modes. We have to select one of the mode. This mode and control. There are 2 resistors, T mode and T-COM. These 2 resistors control the timer operation. So for mode selection, we have to format the T mode. T mode is an 8-bit resistor. T mode is an 8-bit resistor. Lower 4 bits represents timer 1. Higher 4 bits represents timer 1. Lower 4 bits represents timer 0. So this bit I am writing 0. This means it is a gate. If gate is 0, it is a software control. If gate is 1, it is a hardware control. Second bit represents, I am writing here 0. So 0 represents timer. So we can use this 8051 counter as a timer. So now we are programming for timer. So we are writing 0. Next 2 bits represents mode. I am using mode 1. So I am writing 01. 01 means that is mode 1. 00 mode 0. 10 mode 2 and 11 mode 3. In mode 1, timer registers works as a 16-bit timers. In mode 0, 13-bit timers. In mode 2, auto reload mode. In mode 3, split mode. So I am using mode in mode 1. So I am writing 01. So here we are not using timer 0. So we can write all zeros. Now this term becomes 10H. So we have to programming T mode resistor as 10H. So the command used for this one is move T mode, hash 10H. So we have to write here hash. Hash represents it is a data. So next we have to this command this command instructs 8051 to operate in timer 1 and in mode 1. So now we have to we have to load the initial value in the timer resistors. For that one, let the initial value 7634. Let the initial value 7634. H. So the commands used to load the 7634 in timer 1 resistors are move TL1, that is lower byte 34 hash 34, move TH1 hash higher byte 76. So we loaded the initial value and we loaded we programmed as a timer and in mode 1. Now we have to write the program to provide required time delay. Already we calculated the time delay. That time delay is 35.276 milliseconds. So in the last session, we have calculated the time delay for the initial value 7634. So this, if you program the timer like this, it provides the time delay 35 to 76 milliseconds. For this one, I am writing the program. First, mode selection and timer selection. Move T mode. T mode is a resistor. Timer mode resistor. Then H. Next we have to load the initial value. Move TL1 hash 34H. Move TH1 hash 76H. So now we have to run the timer running and timer overflow, either interrupt enable, interrupt type. This all will be discussed in the ELE-COM resistor. Flags, and we can set some bits, and the 8051 microcontroller can set, depending on the overflow of the resistors, some flags. Now I am running the timer. Set B TR1. So timer 1 will be run. Whenever the flag sets, then we have to stop to provide time delay. So suppose for provide continuous time delay clock signal, to provide continuous clock signal, we can keep in this one in a loop. JNB, we are checking the flags. JNB TF1. JNB TF1. If the flag is not set, then we have to repeat this loop. Back. Every time it sets the flag, whether the timer is overflow or not. Counting starts from, whenever we run the timer, counting starts from the initial value 7634 and reaches the maximum value FFFH. So whenever the flag will be set, then it stops. Then we have to clear the timer 1, and we can generate a signal by using any one of the port pin. CPL complement P1.5 or 4, any pin. This represents the port 1 5th pin. So it provides some delay. After that, again if you complement this pin, so one clock signal will be generated with a time delay with a time delay 7 with a time delay 35.276 milliseconds. With a time delay 35.276 milliseconds. For that one, so we are complementing here. This will be 0 and this will be 1. If you complement, we can generate a clock signal with the required time delay. So for that one, this clock signal will be repeated. For repeating the clock signal, we have to keep this one in a loop. Complement, and next clear flag for the next operation, for next counting, clear flag, and then we have to keep in the SJMP again. So continuously it will be repeated. Again can be right here. So again the initial value will be loaded and timer will be run and checking the flag. If it is overflow, then complement the pin number 1.5. So next we can end the program.